Hello students, in this video we will learn exercise 10.2 question numbers from 11 to 17. Now we will learn question number 11. Show that the vectors 2i cap minus 3j cap plus 4k cap and minus 4i cap plus 6j cap minus 8k cap are collinear. Here in this question we are given with two vectors and we are asked to show that these two vectors are collinear. When we will say two vectors are collinear means if and only if there exists a non-zero scalar lambda such that b vector is equal to lambda into a vector. If you show this condition, then two vectors are said to be collinear. For this, let us take these vectors as a vector and b vector. So, our a vector will be equal to 2i cap minus 3j cap plus 4k cap, and our b vector will be equal to minus 4i cap plus 6j cap minus 8k cap. If you observe that b vector is equal to this minus 4i cap plus 6j cap minus 8k cap. So, we will take that one. B vector is equal to minus 4i cap plus 6j cap minus 8k cap. Now, we are going to take minus 2 from all these terms outside. So, if we take minus 2 outside, we will get 2i cap minus 3j cap plus 4k cap. Now, this is nothing but our a vector. Our a vector is 2i cap minus 3j cap plus 4k cap. So, instead of this one, we will write a vector minus 2 into a vector. Here, lambda is nothing but minus 2. Lambda is equal to minus 2, which is a non-zero scalar. So, our vectors a vector and b vector are collinear. So, we can conclude that our vectors a vector and b vector are collinear. Question number 12. Find the direction cosines of the vector I cap plus 2j cap plus 3k cap. We are going to find the direction cosines for this vector. So, let us consider this vector as a vector. So, let our a vector is equal to I cap plus 2j cap plus 3k cap. We already know that we will represent direction ratios as a, b and c. This is nothing but just the scalar components of I cap, j cap and k cap. And also we know that L, M, N are direction cosines of the given vector. Now, how to find L and M and N means here L is equal to A divided by magnitude of a vector and M is equal to B divided by magnitude of a vector and N is equal to C divided by magnitude of a vector. Now, here A, B and C are direction ratios, and now we'll find magnitude of A in order to find the direction cosines. So, our magnitude of A will be root of sum of squares of the scalar components of I cap, j cap and k cap. So 1 square plus 2 square plus 3 square, which is nothing but 1 square is 1 and 2 square is 4 and 3 square is 9. So 1 plus 4 plus 9 is 14. So we'll write root 14. Our magnitude of A vector is root 14. So our direction cosine of the vector A vector is, thus the direction cosine of our vector A vector R, will write within the bracket, that is A by magnitude of A vector. Our A is 1. So 1 by magnitude of A vector is root 14. So 1 by root 14, comma 2 by root 14, because our M is B by magnitude of A vector and our N is C by magnitude of A vector. C is 3. So 3 by magnitude of A vector, which is root 14. So direction cosines of a vector A vector is 1 by root 14, comma 2 by root 14, comma 3 by root 14. Question number 13. Find the direction cosines of the vector joining the points A of 1, comma 2, comma minus 3 and B of 1 minus 1, comma minus 2, comma 1, directed from A to B. This question number 13 is similar to question number 12, because here also we are going to find direction cosines only, but the difference is there they are given the vector directly, but in this question number 13, instead of vector we are given the points, and using these points we are going to find the vector, and after that we will find the direction cosines. Since it is given that it is directed from A to B, our initial point will be A, that is 1, comma 2, comma minus 3, and our terminal point will be B, that is minus 1, comma minus 2, comma 1. So we'll write the given points are A, that is 1, comma 2, comma minus 3, and B of minus 1, comma minus 2, comma 1. And using this initial point and terminal point, we'll find the vector AB vector, which is nothing but minus 1 minus 1. Minus 1 into I cap plus minus 2 minus 2 into j cap, minus 2 minus 2 j cap plus 1 minus into minus 3 k cap, 1 minus into minus 3 k cap. We'll simplify these things now. So minus 1 is minus 2, I cap is there, so minus 2 I cap, minus 2 is minus 4 into j cap, and minus into minus plus, so 1 plus 3 is 4, so plus 4 k cap. This is our AB vector. In order to find direction cosine, we have to find magnitude of AB vector. So magnitude of AB vector is nothing but root of minus 2 the whole square plus minus 4 the whole square, that is scalar component of j cap, plus 4 the whole square. We already know minus 2 the whole square is 4 and minus 4 square is 16 and plus 4 square also 16. 16 plus 16 plus 4 is 36, right? Root 36, and root 36 is 6. So magnitude of AB vector is 6. Now we'll write the direction cosines of AB vector. Therefore, the direction cosines of AB vector are minus 2 by 6, comma, minus 4 by 6, comma, 4 by 6. We can simplify this one. That is minus 2 by 6. If we simplify, we will get minus 1 by 3. And similarly, minus 4 by 6. If we simplify, we will get minus 2 by 3. And 4 by 6 is 2 by 3. So, the direction cosines of AB vector are minus 1 by 3, comma, minus 2 by 3, comma, 2 by 3. Question number 14. Show that the vector I cap plus j cap plus k cap is equally inclined to the axis OX, OY and OZ. Let us consider this vector as A vector. Let A vector equal to I cap plus j cap plus k cap. Then we will find the direction cosine for this vector. Before that, we will find magnitude of A vector. Magnitude of A vector is equal to root of 1 square plus 1 square plus 1 square, because scalar components of I cap, j cap and k cap are 1. 1 square plus 1 square plus 1 is 1 plus 1, which is nothing but root 3. So, magnitude of A vector is root 3. Next, we will write the direction cosines. Therefore, the direction cosines of A vector are 1 by root 3, comma, 1 by root 3 and 1 by root 3. Now, let alpha, beta and gamma be the angles formed by our A vector with the positive directions of x, y and z axis. So we can write, then we have our cos alpha is equal to 1 by root 3 and our cos beta equal to 1 by root 3 and our cos gamma is equal to 1 by root 3. So cos alpha is 1 by root 3 and cos beta is also 1 by root 3 and cos gamma is 1 by root 3. Now if you observe this, it is equally inclined. All the angles are equally inclined. So we can conclude that the given vectors. Hence, the given vector is equally inclined to the axis OX, OY and OZ. Before learning question number 15, we will learn section formula, that is the position vector of point R dividing the line segment joining two points P and Q either internally or externally in the ratio m:n is given by mb vector plus na vector divided by m plus n. This is the position vector of the point R divides internally, and if it divides externally, we will have mb vector minus na vector divided by m minus n. Using this formula, we will solve question number 15. Question number 15. Find the position vector of a point R which divides the line segment joining two points P and Q whose position vectors are I cap plus 2j cap minus k cap and minus I cap plus j cap plus k cap respectively in the ratio 2:1. And first subdivision is it divides internally, and second subdivision is it divides externally. So let us write the position vector of the point P and Q as OP and OQ. So position vectors of the point P and Q are given as OP vector is equal to I cap, from the position we will take and write I cap plus 2j cap minus k cap, and our OQ will be minus I cap plus j cap plus k cap. Now we will write the position vector of the point R as OR. First subdivision is it is dividing internally, so which is equal to, our ratio is 2:1. We will take m is equal to 2 and n is equal to 1. We already know if it divides internally means the formula is mb vector plus na vector divided by m plus n. Here instead of b vector and a vector, we are having OP vector and OQ vector. We will consider this one as a vector and this one as b vector. So if you substitute in the formula, we are having m into, that is 2 into our OQ vector. It is minus I cap plus j cap plus k cap plus n into, our n is 1, so 1 into our a vector is OP vector, that is I cap plus 2j cap minus k cap divided by m plus n, that is 2 plus 1. Now we will simplify, multiply 2 inside, so minus 2 I cap plus 2 j cap plus 2 k cap plus multiplied by 1, we will have I cap plus 2j cap minus k cap. 2 plus 1 is 3. Now we will add the like terms, that is here minus 2 I cap, here I cap. So minus 2 I cap plus I cap is minus I cap, minus I cap. 2j cap plus 2j cap is 4j cap, and 2k cap minus k cap is 1k cap. Divide by 3. So now we will divide each and every term by 3. So we will get minus 1 by 3 I cap plus 4 by 3 j cap plus 1 by 3 k cap. This is a position vector of the point R, which is dividing the point P and Q in the ratio 2:1 internally. Second subdivision is, we are going to find the position vector of the point R, which dividing the line segment P and Q in the ratio 2:1 externally. So we already know OP and OQ. Now we will find OR vector, which dividing the line segment P and Q in the ratio 2:1 externally. We already know the externally formula, that is MB vector minus NA vector divided by M minus N. We will substitute 2 into our B vector is, that is OQ vector is minus I cap plus j cap plus k cap minus our n is 1 into our A vector is, that is OP vector is I cap plus 2j cap minus k cap. Divide by M minus N, that is 2 minus 1 is 2 into minus 1 is minus 2, so minus 2 I cap plus 2 into 1 is 2 j cap plus 2 into 1 is 2 k cap. We'll divide by minus 1 inside, minus 1 I cap, minus 1 into 2 is 2, so minus 2 j cap, minus 1 into minus 1 is plus 1, so plus 1 k cap, divide by 2 minus 1 is 1, so no need to write 1. Now can simplify, minus 2 minus 1, which is minus 3 I cap, and 2 j cap and minus 2 j cap will get cancelled, will get 0 j cap, so no need to write that one, and 2 k cap plus k cap is 3 k cap plus 3 k cap. This is our position vector of the point R, which dividing the point P and Q in the ratio 2:1 externally is minus 3 I cap plus 3 k cap. Question number 16. Find the position vector of the midpoint of the vector joining the points P of 2, 3, 4 and Q of 4, 1, minus 2. Let us write the position vector of the point P and Q first. So we'll write the position vector. Vector of the points P and Q as OP vector. It is 2, I cap plus 3 j cap plus 4 k cap, and position vector of the point Q as OQ vector, which is 4 I cap plus 1 j cap minus 2 k cap. Now we will take the midpoint as R. So the position vector of the midpoint R is OR vector, which is nothing but OP vector plus OQ vector divided by 2. So our OP vector is 2 I cap plus 3 j cap plus 4 k cap, and our OQ vector is 4 I cap plus j cap minus 2 k cap divided by 2. We'll simplify now. 2 I cap plus 4 I cap is 6 I cap, and 3 j cap plus j cap is 4 j cap plus 4 k cap minus 2 k cap is 2 k cap divided by 2. Divide each and every term by 2. So 6 by 2 is 3 I cap plus 4 by 2 is 2 j cap plus 2 by 2 is 1 plus 1 k cap. This is the position vector of the midpoint R of the vector joining the points P and Q. Question number 17. Show that the points A, B and C with position vectors A vector is equal to 3 I cap minus 4 j cap minus 4 k cap, comma B vector is equal to 2 I cap minus j cap plus k cap, and C vector is equal to I cap minus 3 j cap minus 5 k cap respectively, form the vertices of a right angle triangle. So we are given with the position vectors of the point A, B and C respectively, like A vector, B vector and C vector. Using this position vector, first we will find AB vector, BC vector and CA vector. How to find AB vector is B vector minus A vector, or B vector is this and A vector is this one. So 2 minus 3 I cap plus minus 1 minus 4 j cap plus 1 minus 4 k cap. 2 minus 3 is minus 1, so minus 1 I cap, minus into minus plus, minus 1 plus 4 is 3 j cap, and minus into minus plus, 1 plus 4 is 4 k cap. Similarly, we will find BC vector, CA vector. BC vector is C vector minus B vector, and CA vector is A vector minus C vector. After finding BC vector and CA vector, we will find magnitude of AB vector, BC vector and C vector and square them. So we will write without root, because since we have square and square root will get cancelled. So we will write without root, that is minus 1 square scalar component of I cap plus 3 square plus 5 whole square. If you add 1, 9 and 25, we will get 35. And similarly, we will find magnitude of BC vector square, that is minus 1 square plus minus 2 square plus minus 2 square plus minus 6 square. 1 square is 1, minus 1 square is 1, plus minus 2 square is 4, minus 6 square is 36. 36 plus 4 plus 1 is 41. Similarly, magnitude of CA the whole square, it is 2 square plus minus 1 square plus 1 square, which is nothing but 2 square is 4, minus 1 square is 1, 1 square is 1, 1 plus 4 plus 1 plus 1 is 6. Now we are going to add magnitude of AB the whole square plus magnitude of CA the square, it is 35 and 6. We add 35 and 6 will get 41. If you observe now, magnitude of AB the whole square plus magnitude of CA the whole square is equal to magnitude of BC the whole square, which is both 41. So magnitude of AB vector square plus magnitude of CA vector square is equal to magnitude of BC vector square. So ABC is a right angled triangle. Thank you, students.